start by just getting a bit of a sense of the room. I want this to be also engaging. I guess we have microphones here that we can hand out at some point for Q&A. Maybe I'll ask for your help with this. So, show of hands, who knows what MEV is? Let's start with an easy one. All right, MEV Day. I've got the right crew in the room. That's good. I've been to talks before where people didn't know, and it was like, you know, three little hands go up in the room, and that was not that long ago. You know, like even a year ago, MEV wasn't quite what it is today. So it's super exciting to have my people in here. Okay, question number 2. Who is an MEV searcher? Who has done some MEV trading themselves? Put your hand up. All right. Some hesitant hands, you know. Everyone is worried about leaking their alpha, but you know, if you're aware, you got to look around who you have to go talk to. Who is building MEV mitigation solutions or some kind of product that has to deal with MEV? You know, put your hand up. Okay, amazing. And maybe who is doing research on MEV? I think this is another big category. We've got a few hands. Okay, perfect. Okay, so you know, the goal with this event was really to bring up a bunch of people in the MEV industry that have a variety of different backgrounds, get them connected, get them talking to each other, sharing ideas about what the future looks like. And that's what my talk will be focused on, is a mental model for thinking about the future of MEV. So without further ado, let's get started. There's this concept I've been toying around and we've been talking about internally at Flashbots called the MEV Supply Chain. So this we see as being a glimpse into the future of how MEV will be expressed on all the various different domains that users are interacting with. A lot of these actors in the supply chain aren't really known today, or maybe some of them don't even exist. But let me walk you through this supply chain and maybe it will start to click in your head about what these represent. So the user, everyone knows the user, right? This is the one that has been elusive for a long time on blockchain, but finally we're all happy that they've come. And you know, users typically, they don't really know how the blockchain works, or they don't know the details of it, and you don't necessarily want them to know the details of it. But the users always have some intent, they have some intention. They want something out of the product, out of the chain that they're going to use. Nowadays, a lot of that is trading or swapping, right? So a user will have an intent like swap USDC for ETH, and they need help to express that into something that's actionable. So they use a wallet, or they use a dApp, or an aggregator, all these interfaces that help the user express their intention into a transaction. So I'll frame the role of this UI layer as being just that, helping encode intentions into transactions, converting what is sort of amorphous into something that's concrete and is readable by the blockchain. For a long time, the wallets immediately sent those transactions into the transaction pool, into the miner for inclusion. This is sort of the mental model that we're used to, right? Wallets interact with a service provider or a node to propagate the transactions for inclusion. In an MEV world, there's new actors that come into this supply chain. So even if the wallet sends a transaction in the transaction pool, it gets routed to a searcher. A searcher sees that there's MEV with this transaction, whether it's a front-running opportunity, back-running opportunity, sandwiching. They see that there's an opportunity here, and they want to express it, right? So what Flashbots has done, right, is allow for these searchers to have a way to express more granular preferences on the way that they want transactions ordered. And so we've introduced the concept of a bundle, right? So searchers take this transaction, they add other preferences on top of it, and create a bundle. And they want to have a way to communicate that bundle to miners for inclusion. A new role that's just being developed now, and we're in the early stage of seeing emerge, is the builder. So Vitalik will give a talk today about proposer-builder separation and other sort of mitigations for how to deal with the centralization that can be brought by MEV. And a core tenet of that is separating this role of a builder from that of a proposer. So in Ethereum right now, as a miner, right, the miner is both in charge of collecting the transactions, putting them in a block, as well as performing the proof of work and submitting that block to the network. We're seeing that in an ultimate MEV supply chain world, those roles will be separate. So you'll have builders who are specialized at just aggregating transactions and bundles merging them into a block, and then proposing that block to miners or validators for inclusion. So here you have the final level of abstraction, which is the block. So this is framed as a supply chain. It could be framed as a transmutation, but really it's how you convert a user preference into a finalized block, given all the roles and specializations that are emerging around MEV. So this is a mental model. Now, how does this fit into the idea of MEV Utopia and Dystopia, right? This is the sort of the aesthetics of this conference. We have the light room here, we have the dark room on the other side. What does it mean? Why do we see things as being a light future or a dark future? I think this is the core question that we've been asking ourselves at Flashbots. How do we prevent MEV from turning into a dark future? So let's explore what a dark future could look like with this supply chain. We like to reference it as centralized block building. And you can also read, this is TradFi. This is how things work in TradFi. So all of these separate components or different roles that I listed end up being vertically integrated into a single solution. Hasu is giving a talk later today, and he'll go in depth about this dynamic and what are the failure modes in which a supply chain, you can have an actor that vertically integrates up and down the supply chain to create some kind of monopoly. The reason why we don't want this is it's extractive, right? A lot of the monetary flows will flow toward this actor away from the users, and it's centralized, so you can create censorship, and you can undermine some of the core tenets of the blockchain and the reason why it exists today. Another thing that happens with centralized block building is that it's very obscured. So the users have zero transparency on how their transactions are being used, how the MEV is being extracted, etc. So this is the dystopia that we're sort of trying to avoid, trying to move away from. We've sort of seen some hints of it already emerge in the Ethereum domain, and we're seeing even more of it arise when we start looking at other chains. I can give maybe some graphical imagery of what it could look and feel like if we end up in this future. I think what we'll see is that there'll be a lot more co-location taking place amongst bot operators, amongst validators who are operating on multiple different chains. We'll have data centers where you have all of the nodes of the various validators on different chains that are plugged together on a single rack, and maybe manage the majority of the stake on that chain, but they're all physically located in the same place. So this centralization can end up being expressed in a physical way with having the majority of the validating power of multiple networks being in the same place, for the sake of being able to more efficiently extract. Obviously that's dangerous. Obviously if something then happens to that data center, the whole network, multiple different networks can fail, and you have sort of cascading failures. So a lot of this hidden risk is sort of embedded into this structure of centralized block building. Let's talk a bit about what a brighter future looks like. So this is the vision that we have for how the MEV ecosystem can evolve, and the one that Flashbots aims to build towards. So we call it decentralized block building, and it's basically the insertion of markets in between each of these entities, these logical entities in the supply chain, that allows for modularity, that allows for commoditization of the user transactions throughout the supply chain, and fair payment for them. So in this world, the user actually gets fairly compensated for the MEV that they create, and the opportunity that they create, and all the other supply chain actors are collecting some fee for the service that they're providing in pushing a transaction through the supply chain. So you can see here, I've inserted sort of the Flashbots products that we currently have, Flashbots Protect, which really is a layer between wallets and searchers, the Flashbots Auction, which helps searchers express their preferences to the block builders, and then at the merge for proof of stake Ethereum, we'll have also MEV Boost, which is for the separation between builders and validators. So our belief is that if we want to have a healthy future in which there isn't this co-location, vertical integration, monopoly We need to instead have markets that themselves are robust enough to be able to ensure separation between all these actors, ensure that each actor is sort of open to competition, low barriers to entry, so there's new entrants that come into the market and are able to compete with the existing players. I think this is like one very simple way to think about, okay, are we more in the dystopic world or more in a utopic world that everyone can sort of get an insight for? And does the majority of the value go to some mega hedge fund, right? Like, is the entity that you're transacting with some big fund, or is it some protocol, is it some system that returns most of the value back to the users? This is, I think, the key difference by which we'll be able to tell if we're in a utopia or a dystopia, how much of the value goes back to the user versus to large entities. So right now, Flashbots is very focused on developing this system, developing this future on Ethereum, but we see this as being existing on all the different domains. And so our ultimate objective is to work with partners in all these different systems to bring this approach to decentralized block building to other domains. So this is an effort that we're starting now to get in connection with various different partners that have familiarity, that are already developing in these other ecosystems to bring these solutions as part of a holistic MEV network. So yeah, if you're building in this, definitely reach out and we'll talk. So this is my final slide. It's a bit of a troll slide that tries to make the distinction between the MEV Utopia and the MEV Dystopia, try to characterize how various actors can be described in these two worlds. And I actually want to open it up for discussion and questions so that we can talk a bit about maybe the concept of the MEV Utopia, what it looks like, and dystopia, and how it affects these actors. So yeah, feel free if you have any thoughts, question, raise your hand. A lot of the discussions today will kick off of these models and help expand, what does an actual market for bundles or for user preferences look like? What do mitigations look like on other domains? So I encourage you to bring that mental model to those discussions as well. Any questions around the MEV Utopia and Dystopia? All right, do you want to do mics? We've got mic 4. You can just give it.
Hi, good morning. Thanks for kicking off the day. My quick question is, I guess as it relates to the bookends of individuals versus billion-dollar funds, a mental model that I was thinking about is how ASICs and sort of the block production hardware of Bitcoin is maybe something that is a parallel, where it's sort of initially it was more individual, but now there's economies of scale, but still competition. So it's like a weak form version or a hybrid resolution to the individual versus the, I guess, heavily concentrated production side. So how do you think is that an avenue that's also open where it's a blend of individual versus kind of concentrated power as something that could also take place on the block production and ordering side?
Yeah, that's a really good question. I think this is a question a lot of people ask themselves, like, is it inevitable? Is it inevitable that as things become more specialized, more sophisticated, the entities become larger? And I think to some level, yes. Like, specialization means that you're outperforming others. It also means that you have more capital to reinvest. But our thesis is that there's market structure items that you can tackle and you can strive towards to help mitigate that. So I think everyone in this room knows utopias aren't a thing, right? There's no way that we'll actually end up in an MEV utopia, but the best that we can do is strive towards that and take the steps that when you have a decision on design, go in a direction that way. So I'll give a few concrete examples of what design decisions look like that enable more competition, enable more individuals to participate. I think one of the big items on the future of MEV is going to be risk management and inventory management when you're operating across multiple different domains, right? So if you just look at the way that traditional exchanges sort of work, right? As a market maker, you're holding inventory on these different domains, and maybe you're hedging on a third domain to execute your arbitrage or other strategies. This is incredibly inventory intensive. You need a lot of capital that's just sitting idle, ready to transact. So if there are primitives that can be built that allow to have the same, to target those same opportunities with less capital, already that reduces the barriers to entry for participating in that market. So reducing the inventory requirements, reducing the capital requirements is sort of one design approach. I think another one is trying to minimize the risk in execution. So if you're able to convert a lot of opportunities that traditionally are captured in a statistical way, in some probabilistic way, into instead atomic execution, where you can have some guarantees that either you get the opportunity or you don't pay anything, then that also reduces the barriers to entry, because then you don't need to build sophisticated statistical models to be able to participate in some MEV opportunity, but you can do so with deterministic models. So those are, I think, some of the principles that you'd look at for designing towards a utopia.
Thank you.
Question here?
Could you go back to the slide of MEV Supply Chain? First of all, I really like this diagram. I think it explains really well how you should be aware of this part of stack that a lot of people just are not aware of. My question is, do you think there are opportunities there or potential via deploying, for example, knowledge proof schemes, in some parts of this supply chain that could perhaps prevent the issue of MEV this way? And whether you will be in favor of, for example, going for some kind of like end-to-end, fully private, like block building, transaction building, and whether that could be a potential solution, like a way of just avoiding the future MEV dystopia?
Yeah, so let me rephrase the question. You tell me if I understood correctly. Is where does mitigations fit into this? And does privacy help mitigate MEV in any way? Is that right?
Yeah.
Cool. I think, so I would say privacy is the biggest question in MEV, and in particular, transaction pool or pending transaction privacy. So, you know, I don't think there's been a formalized model of like what private primitives are needed. I know there's a presentation on this stage later on by Justin Drake that talks about cryptography and MEV and like what are the cryptographic primitives that we need. But let me riff a bit on this and say like what I think it could look like. So between the relationship, I think, between the wallets and the searchers is one of the most important ones. It's the one where you get to define the boundaries on how user preferences are expressed. You know, right now you sort of act. We see this acting in two models. Either the searchers don't see anything about the transactions that they're receiving, and they're essentially cut out of the system, or the searchers see everything, and then they can do things like front running, like stealing, like all the other bad things. So we're sort of living in a world right now of this dichotomy between, okay, maybe the searchers can do everything, or the searchers can do nothing. But really, we want a world where the user can define and bound what the searchers can do. So maybe the user says, you know, I'm okay with my swaps being backrun because that gives me back some value off the transaction, the MEV that I'm creating, right? When I'm creating a large swap on a DEX, it creates slippage, it creates an arbitrage opportunity that right now the users are just giving to searchers that they're performing arbitrage. If you go with a full encryption approach, with a full obfuscation approach, where you say the searchers don't get a bite at the apple, right? We push it to the next block, we push it to the next transaction, the opportunity will still exist, right? The user doesn't collect the value of the opportunity, the MEV they created, they just pushed it to a different extraction method, which in this case would be like being the first transaction in the next block. So we want something in between. We want a solution where the user says, I don't want to be front run, right? I'm not okay being front run, but I'm okay being back run so long as it transfers some of the value back to me, something like that. And so I think the encryption primitive is critical to be able to, or the privacy primitive is critical to be able to provide those kinds of guarantees, and isn't necessarily something that exists today. You know, another Oh, I'm getting kicked off by the computer. Let me see this. I can give another example, like lower down the supply chain, which doesn't exist today, but I think is going to be critical in the future. So for searchers, right, like once they have, the goal is that they're going to invest a lot in strategies that's going to be able to find MEV and extract it. And that investment into those efforts only makes sense if you have some guarantees that it won't be stolen down the chain. So if the block builder here is able to see all the transactions of the searcher and just like take the best ones and like take those strategies and copy trade them, this model will never work, right? So you need some way for the builder to be able to assemble multiple different bundles and transactions into a block without actually seeing the content of those transactions. And that's not a primitive that exists yet.
Thank you.
All right, another question? Any questions at the back that I can see now? Okay, very good.
Cool. Thanks for the presentation. You talked about in the builder block how it's important for those two roles to be separated out of risk of centralization. Could you talk about the the incentives on why that party would want to decentralize those two roles?
The builder and validator?
Yeah.
Okay, so I think Vitalik's talk after this is going to be focused on this, and in particular with regards to Ethereum and PBS. I can give my perspective on why this separation makes sense. So today, and a lot of the reasons why sort of Flashbots got traction on Ethereum was miners were starting to see that the transactions that they were including had a lot of value, and they were still using relatively unsophisticated ordering systems, right? So we presented them with a model where that said like, hey, here's the concept of a bundle. You can use a bundle to like delegate part of the ordering to third parties, but they still have to do the process of ordering the bundles together. And if they want to go take one step further into saying like, okay, how do I know if bundle A or bundle B or bundle C, which are all conflicting on the same state, can be included together? I need to do a lot of simulation. I need to do a lot of parallel execution of different blocks to try to determine like which block is the one that's the most valuable. And that's just not something that can run on like a single node or a single server. Like you want to parallelize this across a cloud or a network of computers to be able to find the optimal ordering. And if we get into a future where like a validator can only produce valuable blocks if they are able to do that themselves, then we're going to say goodbye to all the dream of solo validators and distributed validators, right? And so the incentive really that you want is for the entities that want to make the investment into doing this simulation work, parallelized simulation work, to still be able to access 100% of the validators, right? And you want any single validator to still be able to interface with this large builder that has built all this infrastructure. So you want to have this many-to-many relationship between these two because they're both incentivized to want to access the best that the other one has to offer. Okay. One more question?
Thanks for the talk as well. Maybe like a pretty practical question, like you were saying about searchers being blind. So when you compare, for example, from the wallet to the searcher step, like Uniswap with CowSwap, like on Uni you can get sandwiched for like 10% slippage. What's different when you use CowSwap in that scenario? Are the searchers blind then, or?
So that's definitely a question for CowSwap, and I think they'll be here. But I think CowSwap is a perfect example of working on this abstraction, right? So as far as I understand, and I'm sorry, CowSwap people, if I get this wrong. I don't know if Felix is here, so they limit the set of searchers that can like get access to the transaction. So I think there's two principles that you can take here. Basically, you need to say either these transactions are only routed to trusted counterparties, trusted searchers that are going to abide by some rules, and that you can kick out of the whitelist if they misbehave, or you have some kind of privacy that's baked in where you say because of these cryptographic guarantees, then you can send it to anyone, and you know that it won't leak the information that would allow for front running. So I think whenever we think of these models, there's always a trusted solution, which tends to be more centralized, and then a cryptographic privacy solution, which tends to be more decentralized and permissionless.
And I guess that's what Flashbots is trying to do.
Yeah. We want to build tools, right, that enable things to be more decentralized. Yeah. We're out of time. 40 seconds. Okay. Perfect. Unless there's any other questions, anything else, then I think we'll make a little transition for our next speaker on the stage, which will be Vitalik. So hold tight, and he'll be on soon.